Okay, so today we will see more problems in the relation to kinematics equations. And please get used to the formula sheet. Could we have the answers for the previous questions from yesterday? Yeah, I will try to post them today. So please get used to the formula sheet, how to use the equations that you have on the formula sheet and all that stuff. Let's go over the example one. An object traveling at 10 meters per second accelerates until the final speed becomes 20 meters per second. If the time interval is 5 seconds, how far did the object travel over this interval? So as we said yesterday, we will start with stating what is given and what they are asking for. So in this case, the initial velocity is equal to 10 meters per second. Final velocity is equal to 20 meters per second. And time in which they are, or the object is traveling is 5.0 seconds. What they are looking for is distance that is traveling. Now you see here that we are ignoring that entering the vector sign, because the assumption that we are doing on this question is that the object is moving on the same direction. Every time that when you see that the direction is not mentioned in a question like this, then what do you have to think is that the object is moving in one direction. Okay, so now what is the formula that relates what is given with what they are asking for? In your formula sheet, please let me know. Okay, so it's formula 5 or equation 5, which I believe you are referring to V final plus V initial over 2 times time. Is that right? Good. So now let's substitute on the equation that we just stated whatever is given. So 20 plus 10 divided by 2 times 5. And now in your calculator, please tell me what is that value through the chat. It is 75 meters, and this is if the correct sig digs, because whatever the question is giving us is with 2 sig digs. The lowest number of sig digs on the given is 2 sig digs. So the final answer will be displacement or distance is equal to 75 meters. Okay, let's move to the second example. A car is starting from rest and accelerates at 5.0 meters per second square at an unknown time interval. If the car travels 250 meters in this accelerating period, what is the time interval? So let's start by stating what is given. So right away, we know that the acceleration is equal to 5.0 meters per second square. And then from the question, we realize that since it is starting from rest, then what is this telling us? What on the chat, please? So its initial velocity is equal to 0. Every time that you see from rest, that means that the initial velocity is equal to 0. When you see that the expression that the object is stopping, then means that final velocity is equal to 0. The distance that the object is traveling is 250 meters, and what they are looking for is time. So what is the formula that relates whatever we have or whatever is given and whatever they are asking? So you are saying equation 2. I'm assuming that what do you mean by equation 2 is the v initial time plus a 1/2 acceleration time squared. Is this the one that you're referring? Yes. Okay. So on this equation, the v initial is equal to 0, and everything that is multiplied by 0 will be 0. So this equation on this particular case will be expressed as d is equal to 1/2 a times t squared. So on this expression now we have everything. We have that the displacement is 250 meters, 1/2 times. Acceleration is 5.0, and then we have the time squared. Let's solve this now. Multiply by 2 both sides. So 2 is canceled out. And then we have 500 is equal to 5.0 times t squared. Divide both sides by 5.0. And then t squared will be equals to 100. And after you square root it, t is equal to 10 seconds. Now, acceleration has 2 significant digits. Velocity is from rest, so it's no need to discuss that. Displacement has 3 significant digits. Since the lowest number of significant digits is 2, then the answer should be expressed in 2 significant digits. So this is the correct answer. This is how you have to state the answer. Do you have any question regarding this? Okay, let's move on to the next example. So we have an object that is accelerating from 5.0 meters per second to 100 meters per second. If the object travels 200 meters during this time, what was the acceleration? So we'll start with what is given. So initial velocity is equal to 5.0 meters per second. And final velocity is equal to 100 meters per second. And distance is equal to 250 meters. And what they are looking for is acceleration. So in your formula sheet, what is that formula that relates all of those quantities that we are either given or looking for? It is, you're saying that is equation 6, which I'm assuming is v final squared is equal to v initial squared plus 2ad. Is that right, Nicole? Yes, excellent. So now let's substitute what is given. So we have 100 squared is equal to 5.0 squared plus 2 times a, which we don't know, times 250. Sometimes I have the tendency to take this equation, and I have this tendency very often because I like it, and then I isolate for the variable that we are looking for. In general, I don't prefer to substitute it like right away, but it's fine to do it. We have done it. You can continue with this way. I will explain to you what to do when you are looking for an expression using the literal equations. So we have vf squared is equal to v initial squared plus 2 times a times d, and we are looking for a. So we subtract vi squared in both sides. So vi squared is canceled out. So then we have VF squared minus VI squared is equal to 2 times A times D. And then I divide both sides by 2D. And I have as an expression for the acceleration of VF squared minus V initial squared, the whole thing divided by 2 times A times 2 times D, not times A. And then from this expression, I substitute what the problem is giving me. So 100 squared minus 5.0 squared divided by 2 times 250. And if you enter this in your calculator, you will 19.95 meters per second squared. And if you are going with the different way, with substituting and doing all that, still you should get the same answers. So on this case, what you will have, 100 squared will be equal to 10,000. So 10,000 is equal to 25 plus 500 times A. So take away 25 in both sides. And then you will have 9975 is equal to 500 times A. Divide both sides by 500. Then acceleration should be the same number, but let's 19.95 meters per second squared. So it's the same result. However, since the sig digs, the lowest number of sig digs is 2, then the final answer will be acceleration is equal to 20 meters per second squared as a result of rounding the numbers. Questions? Okay, let's take a look on this example here. A ball rolls up the inclined plane with initial upward speed of 9 meters per second and stop rolling upward after 3 seconds. Then it begins to roll down the plane. What is the displacement after 3 seconds? After 3 seconds means that at 3 seconds, okay? After 3 seconds, it is moving. Okay, so like everything that we have seen, we will start with what is given and what they are looking for. So we'll start with initial velocity is equal to 9 meters per second. And then time is equal to 3.0 seconds. But then when we see here, a ball rolls up incline at this speed and stops rolling upward. What does that mean? What is this word giving us? Yes, V final is equal to 0. And what they are looking for is displacement. So what is the formula that we will use on this case? Okay, formula 2, which I'm assuming will be V final plus V initial over 2 times time. Is that right, Dylan? But we have to find acceleration. Okay. Okay, this is a very good thinking, Dylan. Okay, your number 2 equation on the formula sheet, it should be this one here. 1 over 2 AT squared. Is that all right? So yes, okay, excellent. Now, there is nothing wrong with the way that you are thinking, okay? Dylan is thinking that from this equation, I will assign this equation 1 and equation 2. Dylan is thinking that through equation 2, we find what is the acceleration. No, through acceleration is equal to V final minus V initial over time, because we have everything through this equation. So through equation 3, we find the acceleration, and the value of the acceleration, we substitute it on equation 2. And this is amazing way of thinking, especially if you are um, away from your formula sheet. Those two formulas are very easy to remember. So then you use them. So you use two formulas to solve the problem. However, we have another one, that equation 1 here on the board, which we don't need to do 2 steps to solve the problem. And the whole purpose of today's lesson is to use as a list as possible steps to solve an equation. So there is nothing wrong with the way that you are solving for acceleration and then using either this or d is equal to v final t minus 1 over 2 at squared, either this or this, and it will work perfect. But equation 1 gives us the answer right away. So displacement, I will use equation 1. Displacement is equal to 0 plus 9.0 over 2 times 3.0. So it is equal to, what is 4.5 times 3 is 13.5 meters. The answer is on 3 significant digits, but what we have here as a given is only 2 significant digits. So the final answer will be displacement is equal to 14 meters. Is it clear to everyone that it's not one single way to solve a problem using kinematics equations? As we stated here, we can use straight the formula V final plus V initial over 2 times time, or we can find the acceleration as a very first step, step 1, and then either go to use equation 2 or equation 4, and we will have the same answer. Questions about this? Okay. So let's move now to the 5th example here. A car is traveling east at 30 meters per second and it applied brakes to generate an acceleration of 4.0 meters per second going west. If the final speed of the car is 5 meters per second east, how far did the car travel in the accelerating period? I want you in your notebook to start working on this question. Love it. Okay, so let's start here. We have a car that is traveling with an initial velocity of 30 meters per second, so going east. And it applies an acceleration of 4.0 meters per second going west. After that, the velocity reaches 5.0 meters per second east. What is this telling you about the acceleration? Is it accelerating or decelerating? The chat, please. Is the acceleration positive or is it negative? decelerating. Okay, so the object is decelerating, so it's a negative. It's negative 4.0 meters per second squared. How do we know this? Because we see that final velocity is 5.0 meters per second going east. Okay, and what we are looking for is the distance that the object is traveling. So now the formula that we will use, or I hope that you have used, oops, it's not this one. The formula that you have used, or I hope that you have used, is a V final squared is equal to V initial squared plus 2 times A times D. Now we are looking for D, so D will be V final squared minus V initial squared over 2 times A. Or if we substitute this, whatever we have, 5.0, and I'm not ignoring the units here. I'm not writing the units because it is everything is in the correct units, so meters per second and meters per second squared minus 30 to the power of 2 divided by 2 times a negative 4. And when you use your calculator, you will have positive 109 meters. However, since the lowest number of sigdigs is 2, then the final answer will be displacement is 1.1 times 10 to the power of 2 meters going east. This is correct work that you have to show if this is a written response question. Questions about this? Okay, let's take a look at the other example that we have here. A man is standing at the roof of a building and throws a stone downwards at 20 meters per second. And the stone hits the ground after 5 seconds. How tall is the building? Okay, so the examples that we have seen up to this point were that the object was dropped. And when it is dropped, we said that the initial velocity is equal to 0. But in this case, what do we have is the object is thrown. So when it is thrown, that means that the initial velocity will be whatever is the speed that they are telling us. So keep in mind, when you are standing at a cliff or at a building, and then you are dropping, the initial velocity is equal to 0. But when you are throwing, then you are throwing it with a certain initial velocity. So initial velocity is equal to 20 meters per second. And the time that the object is traveling until it reaches the ground is 5.0 seconds. And now there is another piece of information here which we do not have it stated in the question, but we assume that it is great, Andre. Acceleration is equals to the acceleration due to gravity, which is 9.81 meters per second squared going down to the center of the earth. But since everything is going down, is in one direction, I'm not assigning the direction here. And what they are looking for is the distance that the object travels from the moment that is thrown until it hits the ground, which will give us how tall is the building. So now the question or the formula that we will use will be V initial t plus 1/2 AT squared. So distance will be 20. Let's substitute whatever we have. 5.0 plus 1/2 times 9.81 times 5.0 squared. So when you enter this in your calculator, you will have to have this in your calculator. So the calculator gives us this. Do you have this in your calculator? I'm waiting for your. Now, the significant digits that we have here as a result of the calculator is 6. And I always say that the calculators are stupid box, but like to be used, so use them. Okay, so now we have to convert this into a number that is only with 2 significant digits. Why 2? Because this is what is given. 9.81 meters per second squared is a constant that is widely accepted that it is. This is what it is. But what the problem gives us is 2 significant digits. So this is how we have to record it. And in order to record it, since we have a large number, we have to use the scientific notation form of the number. So we'll move the decimal point between the first 2. So this will be 2.2 times 10 to the power of 2 meters. Why does it state 2.2? Because the digit that is after the second 2 is less than 5. Great. And now we have next example, and this example is an object is thrown upward with a 49.05 meters per second velocity. What is the velocity at 3 seconds? The velocity after 7 seconds, how long does it take to reach the maximum, and what is the maximum displacement? How will you approach this? I want some comments on the chat. Okay, so for A, what is given and what we will use is initial velocity is 49.05, and it is going up. Okay, so it is going up. Acceleration will be the acceleration due to gravity, which is negative 9.81 meters per second because it is going down. Yes, good. I like, Nicole, I like your comment. And then time is equal to 3.0 seconds. And what we are looking for is the final velocity. So again, it's the same strategy that we have used. We sort what is given. We look for a formula that relates what is given with what they are asking for, relates everything. And the formula that relates it is the acceleration formula. V final minus V initial over time. From here, we find that V final is equal to acceleration times time plus V initial, or V final will be equals to negative 9.81 times 3 plus 49.05. So V final in your calculator will be, so the question was, if the acceleration is positive and negative, shows that it is accelerating or decelerating. Wouldn't acceleration due to gravity be shown as the positive in this case? It is true that the negative and positive acceleration shows if the object is accelerating or deaccelerating. But on this case, the object is deaccelerating because it is moving away from the surface of the Earth. It's going upward. Okay, so now the initial velocity is up and the acceleration due to gravity is down. So we are dealing with a collinear motion. The acceleration is going down and the velocity, initial velocity, is going up. And we know when we are going in the opposite direction to the center of the Earth, then the acceleration, the final velocity will be less than the initial velocity. Does it make sense? Okay, I'm glad that this answer was stated. So this will be in your calculator, will be 19.62 meters per second, and it is going up or going down. Since it is positive, that we stated that the positive is going up, so this will be going up. Now, this is what the calculator gives you, but then in order to express it at the correct significant digits, this will be, V final will be equals 20 meters per second going up. Oops, not with two P's. Going up. And this will be the final answer. Questions about part A of this problem? Okay, let's move to part B of the problem. So part B of the problem is saying that we still have an initial velocity of 49.05 meters per second. That is going up. We still have an acceleration that is equal to the acceleration due to gravity, that is 9.81 meters per second squared going down. And now we are looking for the final velocity at time equal 7.0 seconds. And again, what we will do is we will use the acceleration formula. And same logic as we did it on the first part of the problem. Now I want you to work on it on your own and tell me on the chat what is your answer. Okay, so I see that some of you have the answer on the chat. However, the work that should support that answer is as follows. So we will use the acceleration formula, and then we will substitute in a difference with the previous question. What I did is substitute it here to show you that it's the same, should give you the same answer. So whatever way you are using, it should give you the same answer. Now, as we said, like the acceleration or velocity is going up, initial velocity, and then acceleration is going down. So this is why we say is a negative 9.81. And then substituting everything, the calculator will tell us that final velocity is negative 19.62 meters per second, which means that in the relationship to what we have said as a going up and going down, it's going down. So the final answer, considering the correct significant digits, will be 20 meters per second going down. Any questions on this? Okay, so let's move to the third part of the question. So it is asking you, how long does it take to reach its maximum? So C is dealing with how long does it take to reach its maximum height. We talked about this even yesterday in the class. So when it is at the maximum, what does that mean in terms of the velocity? What is it like? What is the velocity at that point? I want some answers on the chat, guys. It's zero. Is it the velocity is zero? Okay, great. And as Nicole is stating here, is the final velocity is equal to zero. So what is given on this case is initial velocity Initial velocity, as always, is 49.05 meters per second going up. Final velocity, since it is reaching the maximum, is equal to 0. And we are looking for the time. Yeah, how long does it take time? Now, as I said, even on the second part, is the acceleration is equal to 9.81 meters per second squared going down. So now, what is the formula that we will use? Still is the acceleration formula. So the acceleration formula is v final minus v initial over time. And we are looking for time. So this will be v final minus v initial over acceleration. Or time will be v final is equal to 0 minus that the formula is giving you, since is going up is positive 49.05, sorry, over, since it's going down, negative 9.81 meters per second. So time will be, what do you have? So time will be, in your calculator is telling you is 5 seconds. But we have to record it with the lowest sig digs that the problem is giving us, which means that the final answer will be 5.0 sig seconds. Sorry. Questions? Okay. The last part of the problem is asking us what is the maximum displacement. Okay. So meaning that what is the maximum height that the object is reaching. Let's start with the same technique. We say that the initial is 49.05 meters per second going up. Okay. At the maximum, V final will be equals to 0. Acceleration will be equals to the acceleration due to gravity, which is 9.81 meters per second squared going down. And what we are doing is we are looking for displacement. Well, let's use the same strategy as we have used even before. What is that formula that relates V final, V initial, acceleration, and displacement on the chat, please? So Nicole is saying equation 6, and I believe that is this one here. V final is equal to V initial, she is referring to this, plus 2 times A times D. Is it right, Nicole? Yeah. Nicole? Yes. Okay, good. So now 0 to the power of 2 is equal to 49.05 to the power of 2 plus 2 times negative, this is positive, negative 9.81 times D. And even if you don't write the positive, or if it is a negative, squaring up will be still positive. So now displacement will be in your calculator. In your calculator, you should have 122.625 meters. And the calculator tells you that it's positive. However, we have to record it into 2 significant digits, so displacement will be 1.2 times 10 to the power of 2 meters, and it is up. Questions? A rock is thrown up from a 20 meters high cliff with initial velocity of positive 35.0 meters per second. How long does it take for the rock to hit the ground below? So, how will you do this? I will leave you, and then just for clarification, guys, what is given here is that the distance or the height of the cliff is 20 meters, and the object is thrown up because it's positive with a 35 meters per second velocity. And then the path that the object will obtain is something like this. Okay, so we'll go up, reach the maximum. Here is the maximum. And then we'll go down to hit the ground. So this is that is known as the situational diagram. But through this motion of the object, what do we know is that the acceleration is always going down. So the acceleration is the acceleration due to gravity, which is 9.81 meters per second squared going down. So this is the situational diagram, and you're going to add that piece of information here is negative 9.81 meters per second squared. So now what is the formula, and what we are looking for is the time. What is the formula that we will use to find the time here? There were two options on the chat. One was to use D is equal to V final plus V initial divided by 2 times time. But in this case, we do not know what V final is. So we have to go to acceleration formula and then find what V final is, because you cannot assume that the V final is equal to 0. Because we talked about this even yesterday, that we are looking for that slight moment right before it hits the ground, not when it hits the ground, because after it hits the ground, yes, the object will stop. But we are looking for that moment that is right before it hits the ground. So you are on the right track with the idea that you will find the final velocity using the acceleration formula. You can follow this path. The other option that was on the chat was Andre saying that let's use D is equal to V initial T plus 1/2 AT squared. And this is actually where I was leading more toward to. So see what we have. So D is equal to V initial T plus 1/2 AT squared. This is the formula. Because we see what is given and we relate with what is given and what they are asking for with the formula. And this is why you have 6 formulas there, so that you can use the one that fits you the best. Now, what do we see on this case? And this is what, so both ways are fine. You can use that, Nicole, or with finding the final velocity. Is it clear? But see now what do we notice here? So 20 is equal to positive 35 times t plus 1/2 times negative 9.81 times t squared. Or I will simplify it a bit. 20 is equal to 35t minus what is 9.81 divided by 2 is 4.905 t squared. So now what do you have is a quadratic equation. I'm not expecting that you will know how to do it. If you are solving it using math, then you will sort it as 4.905 t squared minus 35.0 t plus 20 is equal to 0. And then the A, using quadratic formula, you can state that A is equal to 4.905, B is equal to negative 35.0, and the C is equal to 20. and use the quadratic formula saying that t will be equals to minus b plus minus the square root of b squared minus 4ac over 2a. I'm not expecting you to do this. What I'm expecting you is to write this equation and then in your calculator state this as y1 and this expression here as y2 and find the point of intersection. So go ahead and do that in your calculator. I believe that you all know how to do this to find the intersection. Guys, it is negative 20 because it is going down. So it's starting from here and it is going down negative 20. Negative 20. Sorry about that. Does it make sense at all? Tell me on the chat this. Okay, so now what we are doing here, we are entering y1 as negative 20 and then y2 as 35 x minus 4.905 x squared. And then we are graphing. So this is what you will see. And then what do you do in order to see the intersection? You modify the window. So the window for x minimum is 0, for x maximum is 10, it's fine. Scale is 1. For y minimum is, I will say, negative 25, so includes the negative 20 that we have entered there, and x maximum 5. So what do you see now is the point of intersection between those two graphs. This is the one that we are looking for. Okay, this graph actually has 2 points of intersections, one that is positive and one that is on the other side that is negative. Since we are dealing with time that is always positive, then we don't, this is why even the window is modified on this way so that we can see only the positive intersection. And then we find the intersect. So second function trace, and we choose number 5. Okay, the calculator is smart, chooses the curves on itself. So first curve, you just hit enter. Second curve, just hit enter again. And then guessing, you don't have to guess, and we'll tell you that the point of intersection is x, which is our time, 7.667, whatever, and y is negative 20, which is the answer, or the distance so that we are finding the time that the object is reaching at. So finding the intersect between y1 and y2 will give us time as 7.66 and so on. Is this the answer? 7 and so on seconds. Now, the significant digits that we have on this question are 3 for height and 3 for the velocity, so will be 3. So the final answer for this question, considering the significant digits, will be 7.67 seconds. Questions regarding, okay, so this concludes today's lesson. You can practice on those practice questions here, which, by the way, are on Google Classroom posted as well, and I will post this lesson as soon as we are done. But complete those practice questions here. Again, if you have any questions or concerns about the course, I have opened a tutorial which will run every Monday through Thursday from 8:15 to 8:45 when we start the TA. So if you have any question, please show up on that tutorial link that I have sent you through D2L and through Google Classroom. Also, open the kinematics equation quiz or assignment on D2L and start working on those questions as well. We will deal with the questions for the rest of the time here with me or tomorrow.